All right, Mr. Solis here. Talking from AQR again, and we're going to be exploring a few things. Number one, I want to make sure before I get into the stuff for today that you understand that we have several different items. Like when to use line reg, exponential reg, and logistic. Now it depends on what you see. If and what you see is what you get, WYSIWYG. And if you see right here under the first one, line reg, you see a line, and with the dots. With the exponential reg, you see an exponential progression of the data, where it keeps on going up and up. And then logistic is basically it starts out slow, goes up exponentially, but then it tapers off and it starts declining, and then we reach this apex where it just starts kind of coasting and doesn't get any larger than a certain amount, and that's populations with limits right over here. We also have this new one, sine reg. Sine reg is used for sinusoidal waves, so we're going to be taking a look at that in this tutorial. So we have this little thing, we have length of daylight. We have several different cities. We have Houston at 30 degrees north latitude. We have Philadelphia, which is 40 degrees north latitude. Winnipeg, 50. And Porto Alegre, whatever. I can't pronounce things too well. So there, Brazil. So we have all these things. We have all this one, this one, this one, and this one. And we have a question. Which city do you expect to have more daylight during the summer, Houston or Philadelphia? So we're going to take a look at Houston or Philadelphia and all that. So, why do you think so and all this good fun stuff. So we're going to be exploring that later on. Now, number one, we have this data from Houston. And they've actually recorded this during the year. So they first went with the first of the month, and now it's let's see, they give you the day number, which is right here, which is going to be our X, and we have this a full amount of data throughout the year. Notice that it doesn't go beyond 365 because there's 365 days in 1 year. Good reason. Then we have this one right here, which is the number of minutes. Number of minutes are basically going to be our Y, and we're going to be mapping this data. It's easier than using the hours and minutes that they give us, but at least we know the minutes that the sun is up on these particular places. 1, 2, 3 is using graphs, and you're actually going to have to do this. So this is the first one. This is for number one. This is the actual graph right here. So it gives us this graph if we go ahead and do a scatter plot of the data. And we're going to go ahead and explore that a little bit later on. So I'm going to go ahead and teach you guys a few things. So we're going to start with the first part of our directions, create a scatter plot. And what we're going to do is basically use this piece of paper that I'm going to give you. It's going to have a basic graph on it. Why am I going through all this? Well, we'll go ahead and look at that later. Don't worry about it. So we're going to go ahead and create this scatter plot that I'm going to give you. And actually, I'm going to go ahead and use the calculator to do this also. Is that these calculators are new and they do things a little bit differently. So first off, you still put in all your data normally. You hit the stat key, you go to edit, and you type in all your data. This is where your X is and this is where your Y. Reason why we don't use the dates is because it's hard to go ahead and point out dates on a calculator when it doesn't know a date from a day. So we're going to go ahead and look at all this. So we have this right here. Now we are going to do a couple of things. I'm going to go ahead and hit second that. I'm going to go ahead and find out what this is. So remember, we know what this is, what this looks like. If I turn on Y and take a look at the plot, zoom 9 will go ahead and give me this nice sinusoidal curve. And on this curve, we see all this data. We see all the data nice and clear. Now I'm going to go ahead and put together my my regression. So I hit Stat, I go to Calc, and I'm going to go down until I find sine reg. There's the sinusoidal regression. So I'm going to push Enter on that, and it brings up this menu. I'm going to keep the iterations 3. I'm going to go to L1 and L2 because those two are really important. And I'm going to store this into y, so I'm going to store this and hit vars. I want to go to y vars, and I want to pick out function, and I'm going to pick function 1. So I'm going to hit calc, and there it is. There's my whole thing. So remember, on the particular form I give you, you're going to record all this information. So calculator form. Let's see, that's 113 sine 0.017. Let me see, that's going to be x minus 1.32, close the parentheses, plus 727. And now we go ahead and get the factored B form. Factored B form is really easy to get. You just take this right here and divide this by that. So we have 113 sine 0.017, another parentheses, x, minus, well, I have 1.32 divided by 0.017, and that's 77, so 78, plus 727. And that's your factored B form. So you can do all the other stuff. Remember that now it's right here inside the formula graph, and it's going to be graphing it really fast. There it is. When you're looking for your maximum, you're going to look for the ordered pair, so you hit second calc, max. You go to the left of the maximum, you have the left bound and right bound. So the left bound is right there. Right bound, it'll be right about there. So let's see. Hit enter again, and that gives you that. So the ordered pair is 172, and this is 840. So on the date, just remember that you're supposed to go ahead and take the day. So let's see, this is 172. So it's in between these two. So I'm going to take 172 and subtract 152. So 20th. So it's going to be June. So this is June 21st. Because on day 152, that's the first day in June. And so we have to add 1 to that. Length of daylight, 14 hours and 1 minute. Now, to get the length of daylight, it's pretty easy. All I do is just this. I just go ahead and take 841 divided by 60. That's 14 hours. I subtract the 14, then I multiply by 60 on the remainder, and that gives me 1. So it's 14 hours 1 minute. I do the same for the minimum, except now when I graph, I'm going to have to go ahead and use second calc, and I look for minimum. There's a minimum right there. I'm going to go to the right because I want to go ahead and go all the way to the right because my minimum is right over here. I'm using the mouse, that way you can see it. So I'm going to go ahead and pick a point to the left in the minimum, push enter, and then I'm going to go a little bit further out. I'm going to try to go as far to the left as I can. There we go. That's as far to the right. I get my left and right confused all the time. And now I push enter, and now I'm going to do the calculation. And that says 359 and 614, which is right here, 359 and 614. Find out the time, 614 divided by 60. That's 10 hours. I subtract 10 because that's the leading number, and I multiply by 60 on the remainders to go ahead and get my minutes. So 14 minutes. And that's it for that. So what you're going to be doing is more of this. You're actually going to be doing something a little bit more, which I'm going to have to go ahead and make a second video because I'm almost out of time on this one. So remember to watch part B. This is part A, and I'll see you later.